In this video, I'm going to be going over the top system design patterns that you're going to be seeing when whether you're designing real life applications or whether you're interviewing in a 30-minute span. You need to like really study and talk about whatever. If I've solved, oh shoot, I'm a software engineer with 5 years of experience. I've read Designing Data Intensive Applications. I've read Alex Shu's Volume 1 and Volume 2, and I've watched a lot of videos on system design. So in this video, I'm going to be breaking down how that works, what's happening, like what are these like top patterns that we're seeing. And I'm going to be starting this video off from basic, super beginner into slightly more advanced. I mean, I would say probably like an average knowledge base that you would need. We're going to start with CRUD applications, so the basic CRUD application. This is the bare bone of what a system design interview is. This is something that a junior engineer should be able to understand. If someone's a new grad, they just graduated college, you have built applications that are CRUD, where you can add data, delete data, update, display data. This is like what like to-do list was as an application. That said, now we're going to pull this up from like a more system standpoint, going slightly higher, which is that like in Google, in Facebook, in Netflix, in Apple, all of these top companies or whatever, like they make trillions of dollars by just doing like these four things, which is why it's like so powerful. It's why it's so important, why it's so powerful. Because yeah, if you didn't know, Apple was valuated at $1 trillion. Tesla is too. And really in general, what they're doing is just adding data, deleting, updating, and displaying. And this is the core of system design. So when you actually have a system design interview, diagram is going to look mostly like this actually. And like 99%, 5 minutes after you get the requirements of the system, you're going to say user, service, and then DB. The user goes into YouTube. They want to see a video, and then the service will look inside, extract the video from the database, and then send it back to the user. And you can apply this out to Facebook posts where somebody wants to see somebody's post. They go, service asks the DB, and then pulls it back. You'll see this in show Twitter feed. You'll see this in hotel reservation systems, Google Drive, Dropbox, whatever. And this is one of those things where you're going to see it all the time. Going up a level further are API endpoints. Again, this is something that a junior engineer should be able to understand, is that this idea okay, we'll start with API endpoints. And again, if you don't know, I'm going to assume that you don't know what an API endpoint is. And this is like, an API is like the basis for web communication. This is what allows you to take data from one location and then send it to another location. And as we talked about here with like this add, display, delete, that's really important. This is what allows you to, grab a YouTube video and download it from a location, or take that YouTube video and then send it from another location. It's what allows you to do like emails, to view your emails and things like that. And the initial part of an API endpoint is that it's just in most cases, it's going to be HTTP. That's just the protocol that we're sending. And these are going to have four main methods: get, post, put, delete. And these methods are going to rarely map onto this CRUD, right? A get is going to be for displaying. You're going to be retrieving some data resource. Put, not generally, but it can create, add data, can update it, and then delete, of course, will be deleting it. And exact things, again, you're probably going to need to know this if you're going to be interviewing, is like, what does it look like? A get is going to be a get at some URL. You can define like the actual thing here. I honestly, I don't even know what this is. I don't really use this, but you can have the host. Authorization, this is going to be really important. You're going to be passing in API tokens generally. So if you're querying, OpenAI's API, or you build your own API, you generally want it secure and to where no random person can access it. So that's going to be the authorization, and then accept. But you need to memorize this for sure if you're going to do interviews. Probably not the host. I don't think it would ask you that, and I don't even think they ever ask you this. But if you're designing an API, yeah, for sure, you want to have these routes out. And then at a step further, we want to give examples of like, okay, what are we sending? And then what are the responses that we're going to be getting? And this is an example of a post, which is going to be adding data. So then we can do a post at a URL, so API/users, and then we can send the data here. And we can also specify what kind of data that we're going to be sending. Cool. And that's essentially it for the API endpoints. Like, again, these are super important because this is the building blocks of the web, essentially, right? So like if you get a question and you want to design Facebook, or if again in real life, if you want to design Facebook, if you want to design Instagram, you need to have these API endpoints. You need to have something that's going to be adding or getting like the users, like your friends, for example, or getting a specific user, you want to see their profile. And then you want something that maybe you want to add a new user. Maybe you want to do a register. This is this is how it's done. And this is something that you're going to be asked about, whether you're a new grad, whether you're mid-level, whatever. It's because this is it's used everywhere. At the next level, we have at the next level, we have caching to improve system performance. Now this is a little bit more advanced. We're moving up, we're going up the scale. And caching is this idea that instead of, if we have 100 million entries, which you will have at the scale of Facebook, Instagram, you'll have millions and millions and millions of rows. What if we just like make a little baby one that's only like 100? That's only of like size 100. Well, now we just increase like the application speed to like 100. Now we don't need to search 100 million. Now we don't need to search 100 million queries, right? We're not going through, oh, okay, I need to go through all 100 million. And at the end, finally, I can get it and find the most popular one. Now we can just create a collection of whatever the most popular ones. Yeah, sure, it's smaller. It's only like the size of 10, but we can get there way faster. So we can also speed this up by using hashing algorithms. So we can use a key value type of lookup, get it in O1 complexity to figure out which one it is, and it becomes even faster than that. And this hashing part is like the meat and bones of this hashing algorithm is like the meat and bones of the cache. And the size is going to be limited, but we're trading size for speed. Now, when is this going to come up? You're going to be seeing a cache to improve systems in almost every system design, most likely. I would say it really depends, I guess, on the question, what they're going to quiz you on. But inside of this like little basic diagram, they generally want you, well, they're going to want to know, oh, how can we go faster? Oh, the follow-up question is going to be, oh, or a very common follow-up question will be, oh, well, how can we improve the speed of this? And then you need to say, oh, well, we could also create a cache. Or like, oh, what if we have millions and millions of rows? How can we improve the speed of this? And the answer to that is going to be you create a cache. And that's, again, something that comes up a lot in designs, is this idea, because it's such an easy way to just win for performance, is using that cache. The next pattern is that I've seen from, just doing all this reading, is a CDN. I see this a lot where it's very similar to a cache, but we're going to be using it for static file delivery. And Cloudflare is an example of this. You use it for Cloudflare. Other places where you would use this is probably Instagram. Instagram, literally any website is going to be caching that information. And the specific thing that's being cached is that is the static files. So we'll cache like the HTML, the CSS, the JavaScript, so we can get those loaded much faster. And CDNs also have like a little bonus where it is actually, CDNs also have like a bonus where they are global. So they actually have global servers like just spread out around the world. So they have one, if this is, I don't know, like if this is the United States, and there's one in like, Europe, one in Asia. So now people can get their data, as opposed to sending data, normally someone has to go here and then request it if the base is in the United States. Now they actually already have a data center here. And so if the person's there, they can just query it. They don't need to go all the way to the United States. And it becomes much faster, much faster than sending, data that far. And again, you're going to see this in Instagram, YouTube, a lot of places where you're just going to have static files. Most web applications have a front end, and most of them are going to be needing something like this. Okay. Now we're going into the big boys, which is horizontal scaling coordination services. So this is the idea that, I guess example of this is Zookeeper and etcd. Kubernetes also does this. If you've heard of Kubernetes, it's it does some similar things to this, where we have now, what if we have too many servers, right? So, okay, yeah, sure, we did the cache here, whatever. What if we have millions of users? If you can imagine, you can't actually store all of those millions of users. Like, let's say our server is like our little M1 MacBook. We can't actually store those servers, like 1 million updates on an M1 Mac. It's not going to be able to have that load. It doesn't have the CPU. It doesn't have the RAM. And this is a pattern, again, that can be tossed at you, is what can you do? And the answer to this question is a coordination service plus a load balancer. So on the aspect of a load balancer, this load balancer is this idea that we can take something and then we can start routing it. So we can add a layer in here so that when the user requests, they actually request here. This is what they're actually requesting, and this is the load balancer. And then this is what it's actually, I guess sending, or actually I guess it would send it to the user. The load balancer would take it and it will say, okay, well, we have all these services. We make multiple services is one. And then we distribute it to whatever one, we send the user to whatever one has the least amount of load. So like here. And when we do this, we can scale up. Now we can actually do 1 million, because each one can probably only need to do like some X amount of work. Now the problem comes in, which is what happens when this one like breaks, for example, like let's say, I don't know, it's tired, it's gonna retire and it's gone now. Well, now I can't route it to here and I want to make a new one. And I don't want to have to keep going to my code base every single time to do that. So that's where a coordination service comes in. And Kubernetes has this idea, it's called self-healing, where it's able to create a new one in its place. And not only is it able to do that, but it's able to say, oh, you're down. Okay, well, if you're down, then I'll just make a new one, right? So it's two ways faceted. And so this is what Zookeeper is doing. It's able to say, oh, well, these list of servers are down. We should reboot these, or we should route traffic to somewhere else. And how does it know? There's health checks, if you didn't know that. So what it'll do is the server will constantly send in like, I'm okay, I'm okay, I'm okay, I'm alive. And if the service doesn't get I'm alive, then it's going to assume that it's dead after some period of time. Ways to send data. This is the next pattern. And it involves different applications where we're going to be sending data. So what I talked about earlier was just CRUD, like HTTPS, like we're just going to send it from here to here, here to here. Super basic. We want to do an update. Okay, well, we're going to send it. We use HTTPS. We're going to be using Git, Post, whatever. But there's actually it's not the best one. Or it's not even like the only one option that we have. We also have message queues. So if we want to, generally we're going to use these anytime we want to guarantee that we never lose data. And that's going to be if we need to send a confirmation email after somebody like paid for our application. If we are doing something like Facebook Messenger, we can put things into a message queue and that'll assure that it never actually gets lost and will actually 100% will be delivered, which is great for messaging apps because we don't want to have it go away, disappear into the ether, and we've never hear about it again. This applies to the server side event, server sent events like notifications that you want to send to another server, pub subs. Is really great for using message queues for things like that, where you've got people who are subscribing to some kind of topic and you want to send it out to them. gRPC is super, super fast, and not super fast. I mean, it's fast. It's faster than HTTPS, and we can do out low latency notifications using that. And there's also WebSockets, and in WebSockets, we're going to have a two-way communication between points. It's more complicated to set up, and it's also more resource intensive, but it gives us real-time updates. So we're going to be using these in applications where we want real-time updates. So again, Facebook Messenger can also use this if we want real-time, or real-time location updates. So if you want to be able to see your friends, if you want to see where your Uber driver is, you can use something like a WebSocket to constantly send out that information in real time. And in these applications, that's where you're going to be using these. But it's important to know that there's just different ways that you can send them out, and there is a choice. And most of the cases, it's just going to be these four. And there's also ways that you can also send data. So you can use JSON, you can use XML, you can use SOAP, and you can also just send pure binary, which is more complicated, but is faster. Okay. Now we've gone over this. We're going to go into harder difficulty, which is relational database design. So when are you going to see relational database in your system design journey? You apply to a company that only uses SQL or relational databases, or your interviewer really wants you to design or answer like trivia on relational databases for whatever reason. Most likely it's because of the case that you applied to a company that uses relational databases. So they're going to be asking you things like, this is way out of scope of this video, but they are going to be asking you, what is normalization? What is denormalization? What are the pros and cons of it? What is indexing? What is sharding? What is replication? What are constraints? Can you design a table? One pattern that I'll see is that you have a table for, a SQL database, and you will have like the users table, right? And then you'll have like the friends, I guess, of like a user or whatever. And you want to create like a third table that has like a user to friend relationship. So you can see like which user is like user ID 1, for example, would be here. And then like user ID like 2 or whatever. And you just want to see like, are they following each other? And so you can do like some kind of join based off this to have like their relationship. But again, this is out of scope. And if you're struggling with that, you can look into these yourself. I'll put it into ChatGPT and it can give you an answer. Next pattern, there are applications that are strictly on geolocation, and that's where these geolocation patterns are going to come from. There are applications that use geolocations. So you're going to see this in Google Maps, Uber, Snapchat, Tinder. Any application that wants to know where you're located at and it's using that to compute things, like this is where you need to use these geolocation based patterns. And this is going to involve geocoding, right? How do you convert 308 Negra Aurora Lane, Albuquerque, New Mexico into latitude and longitude, right? But this is what geocoding is going to allow you to do. Geohashing, you can convert latitude and longitude into like a 0, 1, 2 grid, and you can kind of just base down at each level. So you can say this is the first level, right? Like this is another level, this is another level, this is another level, until you can narrow down. And this allows you to to take a latitude and longitude and then convert it into a system of levels into specificity. So each level here, if I had like 1, 2, 3, 4 or something, for example, all right, this is gonna narrow it down. 1 will be like the whole northeast side of the world, of the entire globe. And then as we go down, we'll go into northeast side, but like leveled down onto the 2, northeast side, leveled down into the 2, right, which is like maybe east or whatever, or west, and then drilling down. And it's kind of recursive as we can keep going down, 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 down into the levels to get even more specific. We have quad trees too. And these are going to allow us to perform range queries. It's an in-memory tree that's going to have 4 leaves, north, south, east, and west. And everything that's on the north side, we place those inside there, and then we can recursively go down when we need to search for things. Again, really good for range queries because we can just use recursion if we want to find something that's next to something. Okay, and we're almost done with these patterns that I've seen. So there's batch services. This is another pattern. So we've kind of done kind of like async services so far as what I've talked about, but batch services are when we have a ton of data and we need to like process it. And it's okay if we do it like offline or in a different like location basically. And so you're going to see this in metrics monitoring, ad click aggregation. For metrics monitoring, you're going to have a ton of metrics and you want to like condense them down and get the ones that you really care about. You need to like process all of that raw metric data and then like put it into somewhere else. So there's 2 options for this. You can do you can create 2 separate databases, one for all the raw data and then one for the process data. And then you can run analytical queries. So this is, again, like something like an OLTP database and then have an OLAP database. And then the second kind of idea here is that you can use MapReduce, which is a kind of merge sort. So what you can do is you can take all that big data and you can just break it up and break it up and break it up. Actually, before I talk about the MapReduce, I do want to talk more in detail about the OLTP and OLAP. So essentially an OLTP database is a database that you're going to be performing like, again, those basic CRUD application, types of queries. And then a OLAP database is very different because it's structured differently. And this can be like something like a time series database, but essentially imagine you have like a ton of metrics for, some CPU, like CPU usage at, 5, or like, I don't know, like 05, wait, 2003, whatever. But you want to be able to query these and it's going to be different than this. And so this can be things like a column, based as opposed to like row based, which is where we just have like a list of CPUs at certain dates, or we, format them in different ways where instead of, the primary key being in a standard way where it's like, oh, ID, and then like the row has like the CPU at the given time or whatever, and like the dates and all that, you adjust it. So now you have a date, and for a given date, now you have all of like the CPUs. So you have like CPU at 1, or like you have like the CPU usage at time 1 or whatever for that, for that given date. This is row based, right? ID into CPU usage, and then this is like date into like CPU usage. So it could be like, as an actual thing, it could be like, I don't know, 50 milliseconds. I don't know. Or like 20 degrees Fahrenheit for 1, 30 degrees Fahrenheit and whatever. This is the idea of like OLAP databases, that we can use something in like a time series as opposed to relational to do that. Next, for the MapReduce, you're going to notice that, or for MapReduce, it's going to allow us to do, again, this batch processing. So offline, we can have a series of workers that are going to be, these are like just mini servers, whatever, could be Docker containers or whatever, but they're going to be processing. They're going to be pulling data from our database. So we're going to have like, some database, and then we're just going to have it. We're going to have some other ones processing it. So they're going to be sending here, sending data into here, sending data into here. And then now they're going to start working, all of them. And then they're all going to start outputting something. This is the idea of MapReduce, which is that like a really key example of this is if you have like a leaderboard, or you have like, again, ad clicker, or any other application where you just have like, you want to get like the top, 3 values in it, and you have like a ton of data, like let's say millions of data rows. You can just split those data rows up, say, oh, the first 5 are going to go here of the data rows, the first, next 5 are going to go here, next 5 are going to go here, and then you have these sort them, and each one of these will give you their top 3, right? And each one of those gives you their top 3, and then you combine them. And so you say, oh, okay, well now I have these, and these are going to give me a top 3, right? And you just keep going that until now you're only left with 3 that are the top. Very similar to merge sort and kind of a divide and conquer strategy. But this is a very important, kind of algorithm because it solves these problems. This leaderboard, ad clicker, whenever you just want to get the top 3 values of something, which is pretty common. There's a lot of applications that are doing that. There's Spotify, Amazon, like, top 3 products or whatever. It can go on and on and on. Facebook, I'm sure, has like some kind of ranking system, and these are all available just because of the, what we have is batch services. It's this idea of you offload to some offline thing that's going to be pulling the database and processing it. Next pattern is streaming services. So there are times where we want real-time data, and there's ways that you can do that. The first way is that you do double writes on the data and you just keep 2 copies of it. So if you ever need to use Elasticsearch, so if you want to search tweets in real time, you can use Elasticsearch. That can make it like lickety split real nice. Or if you want like a real-time leaderboard, you can just write twice to like a different location. This is called a change data capture. DynamoDB has this like built in. Kafka is used very commonly for using like this change data capture where you just pass it in again to a message queue. Kafka is a message queue, by the way. And if you remember what I talked about message queues, is that they never lose the data. So it'll get there eventually. So you can kind of have near real-time stuff like using this change data capture. There's also actual, other ones, which is like Spark, Apache Spark, which are built for doing these types of things. Again, if you want to look more into this, you can. I'm kind of, glossing over this very quickly, but to make this video a little bit shorter, but, you can do your research into like the stream services and what options you have, but this is a solution and this can work. Again, yeah, that's fine. Okay, and going into actual like system design types of problems. So how do you prevent double bookings? This is a problem that will come up a lot, and where interviews will test your knowledge, and generally that's going to come up when you're asked to design Ticketmaster, hotel reservation system, flight reservation system. But the worst case scenario for this is that you have 2 people who try to book something at the same time, and like what should happen and how do you prevent that from happening? What can you do? Which is, we're going to see 2 concepts, which is pessimistic locking and optimistic locking. Pessimistic locking is going to be this idea that if we have it, we have one person, whoever gets there first, they lock it and make sure nobody can take it until they finish. And whenever that happens, that if somebody's trying to buy a flight, that means that like as they're buying the flight, that flight is unavailable. Like you cannot access this flight. Imagine, you go to buy like a seat A1 of the VIP section or whatever, and you're just sitting there thinking with your credit card in your hand, do you really want to do this? You're going to be blocking that from everybody from being able to do it. Now, optimistic locking says that anyone can grab it. Anyone can start like filling it out. It's not blocked yet. And then once whoever gets it, they get like a version 1. And then whoever has the version 1 is the one who gets to take it. And so this can lead to people thinking that they have the seat booked, which could be like, user dissatisfaction, because they think that they bought the ticket, but in actuality, like they get the success page and everything. But in reality, it never actually went through. So these are like the 2 ways of, kind of dealing with that. And then finally, we have independency, which it's lesser known, I think, as a pattern, but it can come up. Typically, when you're doing Stripe payments, sending money at a bank, is this idea that whenever you have a system and you do some kind of operation, on that system. So let's say that like we want to withdraw $1 million from our bank account or something, or we want to send $1 million in from our bank account. So we take that million, we send it over, to the bank, and then the bank's API says, okay, cool. We actually failed, but in reality, they actually did succeed. And then they do take it from your bank account. So then your bank goes to, to like negative or to $0 or whatever. Or let's say you're rich. Now let's just say it's at $0. So then your bank goes to $0, but it actually didn't work for you. So then you try it again. And actually in this case, it actually would be better if we said like it's like 2 million. But so let's say now you go from 1 million to 2 million. Or okay, hold on. You have $1 million. You try to send $500,000. So let's say you have $1 million. You try to send $500,000. You get a rejection. So it says, no, it actually couldn't do it. But in reality, it could do it. And it's sending your money all the way over to the person. But you never got a confirmation for it. So you try it again. And now what you end up doing is you send all of your money. So now you're left with $0 because you did it twice and executed twice. So this is something that's a no-no. We do not want 2x like double purchases. We don't want double charges. And this comes up a lot with money, I think. And the key to this is that you can cache it. So what you can do is you can have a cache, if you remember what we talked about last time, which you say, oh, well, user ID, like just try to request at like 5,000 seconds. Let's see what the result of that was, because you just did this 5 minutes ago. So let's see what it was. And then we'll look in the database, or we'll just cache the result of like what it was. So like user ID, we can mark it as success or whatever. But the issue is that like this thing can fail here because just network, like the internet went out. But if we check here and we're like, oh, it says success, then we know that, it's good and we can actually do this. So these are just deep dive questions that you can get asked when you're building out these systems, which is how do you prevent stuff like that from happening? And yeah, again, it's just you cache key to value, key to value, key to value. Just realize you couldn't see what I wrote out there, but it was this. And that is it for the system design pattern. So overall, like congratulations if you finished this video. This is not, this was not like a lot of easy stuff, especially if you're like a complete beginner, but this is how like this is, in my opinion, from reading all those books, like this is like my knowledge on the common things that I've seen in system design, like interviews, and in system design real life applications, and how to build them scalable and all that stuff. And if you know these, like you're good, I think, for a lot of it. So thanks for watching, and I'll see you guys later. If you're struggling with interviews, you can join my school community. There's a link in the description below. Thanks, and good luck in your interviews.